Hello friends, this video on relation and functions part 6 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched relation and functions part 1 to part 5. Let's draw some graph now. Graph identity function. It says fx is equal to x. Domain and range both are real numbers and the graph is a. Let's draw this. So when you say fx is equal to x, you are saying y is equal to x. And let me draw the value here. For x is equal to 1, y is equal to 1. For x is equal to 2, y is equal to 2. For x is equal to 3, y is 3. For x is equal to minus 1, y is minus 1. For x is equal to 0, y is 0. Let us plot these values in the number line. X is equal to 1, y is 1. X is equal to 2, y is 2. X is equal to 3, y is 3. X is equal to 4, y is 4. X is equal to minus 1, y is minus 1. X is equal to minus 2, y is minus 2. You see, this is 1 comma 1. This is 2 comma 2. Because x is 2 here, y is 2 here. This is again 3 comma 3. And this is 4 comma 4. So you draw this graph like this. You get a graph like this. So straight line. Not able to draw a straight line, but it is a straight line, and this is called identity function. So whatever is the value of x, the same is the value of y, so it's identity function, and the graph is a straight line. The domain and range both are R. So the x-axis is the domain and the y-axis is the range. So y is range and x is domain. You see, x can take any real number and y can take any real number. Now let's take constant function. In constant function we say fx is equal to k. Here domain is R and range is only k. And it is a parallel line parallel to x-axis. Let's take an example. When we say fx is equal to 4. So you say y and you say x. You give any value of x. You say x is equal to 1, the y is 4. You give x equal to 2, y is 4. You give x equal to 0, y is 4. You give 3, y is 4. You give minus 2, y is 4. So for any value of x, y is always 4. We'll plot this. When you give x 0, y is 4. When you give 2, y is 4. When you give 4, y is 4. When you give minus 2, y is 4. Minus 4, y is 4. For any number, y is 4. So this is a straight line parallel to x. So if you see here, the domain, that is x-axis, is R. Any real number can take this value. But the range, you see, the range is 4 because 4 is the only output. So in this case, domain is R and range is 4. And it is a line parallel to x-axis. Let's take an example of polynomial function. Polynomial function is of form a0x, a1x, a0, a1x, a2x square plus a1x square, x to the power n, where n is a non-negative integer. N, a1, a2, a3 are all real numbers. Here domain is R. We can give any real number, but the range depends on the function of x. And the graph is also, it depends on the function of x. For example, let's take function fx is equal to, we'll take function fx is equal to 2. This is 2. Let me take this as 1, take this as 1, the other as 0. So it will be 2 plus x square. This is the function. Now let me create y and x. Now I give y as x as 0. You give 0, y is equal to 2. 2 plus 0 plus 0. You give x is equal to 1. What you get? 2 plus 1 plus 1. That is 4. You give x equal to minus 1. What you get is minus 1 plus 1, 0 plus 2, 2. You give x is equal to 2. What you get is 2 plus 2 square, 4. That is equal to 4. 4 plus 2, 6 plus 2, 8. This is 8. You give minus 2. What you get? Minus 2 plus 2, 0 plus 2 square, minus 2 square equal to 4. Similarly, you give 3, you get 3 square 9 plus 3 12 plus 2 14. And you give -3, you get -3 plus 2 -1. -1 plus 3 square 9 is equal to 8. So you'll get something like this. Now let's plot these points in the graph. So when x is 0, y is 2. When x is 1, y is 4. When x is -1, y is 2. When x is 2, y is 8. When x is 3, y is 14. Somewhere here. When x is -3, y is 8. Somewhere here. And x is -2, y is 4. So if you plot this graph will come something like this. Somewhere it will touch 0. It will be of this form. Correct? This is the graphical representation of this function. So here you see the graphs which you get. It all depends on the function we are taking. So we say the graphs depend on the function, and the range also depends on the function. Now let's take rational function. Rational function is the form of fx by gx, where gx is not equal to 0. Obviously, if you make gx is equal to 0, it will become infinity. Example is fx is equal to 1 by x. And here also range, domain and range both depend on x. In this case, both domain and range depend on x, because if I say 1 by x, then x can't be 0. There is an issue in domain. Domain is not dependent on x. And if I say 1 by x minus 2, here also x can't be 2. So the domain also depends on the function. Range also depends on the function. Let's draw this graph. Fx is equal to 1 by x. So we'll say y is equal to 1 by x. This is x, and we get y. So you say x is equal to 0, y becomes infinite. 1 by 0. You give x equal to 1, y become 1. X equal to -1, y become -1. X equal to 2, y become 1 by 2. X equal to -2, y become -1 by 2. X equal to 3, positive 3, y is equal to +1 by 3. X equal to -3, y become -1 by 3. Let's plot this. X equal to 0, it's infinite. We can plot this now. X equal to 1 is 1. 1 is 1. X equal to -1. Y is equal to -1. This is the point here. X is equal to 2. Y is equal to 1 by 2 is equal to 2. Y is equal to less only. Less than this. Correct? And x is equal to -1 by 2. Y is equal to -1 by 2. It is further less. It is here. And for 3 it will come somewhere here. It will come here. So x equal to 0, y is equal to infinite is here. Infinite is this, positive infinite. So we'll draw graph from here, from infinite. It comes and it goes, if you give infinity, it goes to 0. Similarly in this case, when you give if you give 0, y is equal to again infinite, correct? So y is equal to infinite, minus infinite, sorry, not drawing correctly. And here it is bending like this, because if you give minus infinity, x is equal to minus infinity, y will become almost 0, so it will touch to almost 0. But if you give x is equal to almost 0, it becomes infinity. This is the graph of 1 by x. Again, the graph depends on function to function. Here in this case, domain, range, everything depends on function. Now we'll see modulus function. So modulus function is fx is equal to fx module x. If you give -1 as the input, you'll get 1. If you have -2, you'll get 2. So whatever value you provide, you get the positive value. And here, domain is R, you can give any real number. But since it always gives positive number, the range is R plus. We'll draw this. We'll take x and we'll take y. When we give 1 as the input, the output is 1. When you give -1, the output is 1. When you give 2 as the input, the output is 2. When you give -2, the output is +2. So any negative number you give, you get the positive output. Let's draw this. If you give 0, you get 0 output. You give +4, you get 4 output. Let's draw this. 0 is 0. you give 1, you get 1 output, you get 2, you get 2 output, you give 3, you get 3 output, you give 4, you get 4 output. But you give -1, you get 1 output, you give -2, you get 2 as output, you give -3, you get 3 as output, you get 4, -4, you get 4 as output. So the graph is something like this, this, and this. So if you observe, the output is always positive. So it says the range is always positive, R positive. But the domain, the x-axis can be anything, positive or negative. So it says domain is any real number, but the output, that is range, is always positive. So we can see all these things from the graphs also. That we have seen made this graph, and from the graph we see x can take any values from -infinity to +infinity. So we'll say domain is R. Y can take only positive values. So we'll say range is R positive. Now we'll take graph of signum function. So what is signum function? Signum function is x is equal to 1 if x is greater than 0, x is equal to 0 if it is exactly 0, and x is equal to -1 if it is less than 0. Now let's create y and x. Y is equal to fx here. So if you give 0 as output, you get 0. If you give 1 as output, you get 1. If you give 2 as output, you get 2. Sorry, you get 1. If you give 3 as output, you get 1. Similarly, if you get -1 as output, you get -1. -2, again your output is -1. You give -3 as the input, you get -1 as the output. Because it says for any number less than 0, it is -1. To draw this, for 0 it is 0, that is confirmed. We can plot this point. For any number greater than 0, let's suppose 0.001, it is here. It is here. 1. For 2 it is 1, for 4 it is 1, for 3 it is 1. All these points are there. Similarly, for minus 1, it is 1. Sorry, 1. This is cancelled. -2 is 1. For everything, it is 1. But you see, for 0.00 only, it's 1. If you say 0.0001, this is 1. But for 0, it is not 1. So this is example of open interval, which we have studied. And we know our memory tip, ONE, that is open, no endpoints. There is endpoint is not included, so it is open interval. And open interval is denoted by a light box. So we'll create a light box here, and here also we'll create a light box, and we'll extend this line. This is the graph of signum function. Repeat. Signum function, for any number greater than 0, it's 1. Any number less than 0 is -1. And for 0, it is 0. Since for 0.0001 also it is 1, so it is example of open interval. And in open interval, you use white box, white circle. So we have used the white circle, not a dark circle, and we have plotted the points. This is example of signum function graph. Here, domain is R and range is -1, 0, and 1. You see, you can give any value as the domain, but the range is either 0 in case of 0 or -1 or 1. So from graph we can say what is the domain and range.
Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors,